Welcome back. In this part of the course, I want to spend some time introducing all the key components of Docker. We are going to focus on what each component is, what it does, and how these components interact with each other. This is one of the most important sections of the course because it lays the foundation for everything else we'll be learning. So let's jump in and get started. I want to keep this part of the course high level. I'm not only introducing things now before you can learn about them in detail and use them practically later in this course. Now, when you hear the term Docker or Docker engine, think about a client-server application. We start with the Docker host, and it's a Docker host because it's running the Docker daemon. This is the part which does the heavy lifting. It's the brain of the Docker platform. This is the server part of the Docker engine, client-server architecture. Docker Daemon is a long-running service and it provides API access to be able to interact with it. The API access is used by Docker clients, which are the client side of the Docker engine. This can either be the Docker command line or Docker desktop, but it can also be applications which you or a developer might code, which interact with the Docker daemon directly. Now, on the Docker host, under the control of Docker daemon are two things: containers and container images. Now, there are other elements such as storage and networking, but I'll be talking about those in much more detail elsewhere in the course. We gain nothing by overcomplicating it at this point in the course. There's another component which I haven't mentioned yet, and that's a registry or a hub. And this is a private or a public store for Docker images. Images are used to run containers, so if you want to run the application within a container, you need to have an image which has that application as well as any libraries which it uses or any runtime environments and registries to store these images. So in this example, you might have a base Linux image or maybe an image of a game server. In this case, let's assume both are public. Now, to run a container on a Docker host like ours in the middle in this example, we need to have images on the Docker host itself. And we can get images in two different ways. We can download them or we can create them on a Docker host. To download Docker images onto a Docker host, we need to run Docker pull command via the Docker client. And this would communicate with the Docker daemon, which would pull those images down from the registry onto the Docker host. Another way you can obtain the Docker images is to create them. And this is done using Docker build commands via the Docker client. This command takes as an input something known as Docker file. Now, a Docker file is a list of directives or statements on how to create a Docker image. And don't worry, I'll be covering this later in the course. You are even going to create your own. The client gives the Docker file to the Docker daemon, and the Docker daemon uses this Docker file to create an image. Once you have one or more images running on the Docker host, you can use the Docker run command, and the Docker daemon will use this command to run containers using Docker images. A container is just like a Docker image. Only instead of being read-only, we add a read-write component and this becomes a container. It allows data to be stored within that container and allows the container to be run on Docker host. You can also, once you have created images, push these into a registry, for example, Docker Hub. And again, this can be public or private. And you can do this by using Docker push command. Docker push command takes an image from the Docker host and pushes into a registry. Now, at a high level, this is the architecture of a typical Docker deployment. You might have one host or 100, one image or thousands, one container or many containers. The architecture at high level is the same. Now, there are many other components that I have yet to talk about and I have kept this to a high level. So there are certain things that I have said that do have some technical nuance. But this is the foundation that we will build on and expand as we move through this part of the course. At this point, though that's everything that I wanted to talk about right now, I hope it was understandable. If not, just go ahead and watch this part of the course again. Otherwise, when you're ready, go ahead and move on to the next part of the course. In my previous video, I told that Docker is a virtualization software. But how exactly a Docker is different from virtual machines? We'll see that in the next video. Thank you.